Hey guys! Recently, Black Forest Labs released their newest image generation models under the name Flux2 Klein. This release includes two base models, the 4B and 9B, along with their distilled versions, which only need 4 steps to generate an image. These distilled models are lightning fast. All of these models can perform text-to-image generation and are also capable of image editing. In this video, I am going to focus on editing with the 9B distilled model. So, let's get started. First, let's see where we can get the 9B distilled model and its related files, then where we need to put those files inside ComfyUI. The download links I am using here are available in the description. Open the link for the 9B distilled model and you will see a page like this. To download the model, you need to have a Hugging Face account. If you are a beginner, don't worry, you don't need to pay anything. Just create an account and agree to their conditions. After that, go to Files and Versions. Here, we can find the 9B Klein model named Flux2 Klein 9B.SAFA-tensors. Use the download button to get it. If your computer cannot handle this model, you can find other quantized models as well. Let me show you those. First is the FP8 model, which is also provided by Black Forest Labs. The file is named Flux2 Klein 9B FP8.SAFA-tensors. This model is quite a bit smaller, coming in at around 9.5 GB, so use the download button to get it. If you cannot run that, the NVFP4 format is also available. Let me show you that. If you open the link for NVFP4, we can find the file named Flux2 Klein 9B NVFP4.SAFA-tensors. This file is even smaller, which makes me think you might not even need GGUF models. You can use the download button to get it. However, if you prefer to use the GGUF models, those are also available and provided by Unsloth. You can try any of these quantized models depending on your hardware, so just use the download button to get the one you need. Next, we need the text encoder. When you open the link for the text encoder, you can see 3 different formats of QN38B. If your computer can handle the bigger one, download that. If not, download the FP8 mixed or the FP4 mixed. Next, we need the VAE model. When you open the link, you will find Flux2 VAE.SAFA-tensors. If you have used the Flux2 dev model before, you may already have this file. If not, go ahead and download it. After the downloads are finished, let's see where we need to put the files inside ComfyUI. Let's open the Downloads folder. As always, I am using the portable ComfyUI. Open the Models folder inside ComfyUI, and in here, there is a folder called Diffusion Models. Let's open that. This is where we put the Flux2 Klein 9B models, no matter if you are using the FP8, the NVFP4, the GGUF, or even the base models. Now for the text encoder, let's go back to the parent folder. Here, find and open the folder called Text Encoders. This is where we put the QN38B model. Whether you are using the FP8 mixed or the FP4 mixed, the text encoder should be placed here. Finally, for the VAE model, go back to the parent folder again, then find and open the VAE folder. This is where we put the Flux2 VAE.SAFA-tensors. After putting all the files in their places, we are ready. Let's switch over to ComfyUI. If you moved the files while ComfyUI was running, I suggest refreshing it by pressing R on your keyboard. The workflow I'm using here is the same one I used for the Flux2 dev model in a previous video, but with some changes, I added to support the new Klein model. You can download this workflow from the description. Let's get a basic understanding of how this works. Focusing on the left side, we have the Load Diffusion Model node, which loads the Flux2 Klein 9B model. If you are using the FP8 or the NVFP4 model, select it here. Later, I'll show you how to add the GGUF model to the workflow. The model output from this node connects directly to the K-sampler model input. Next, we have the Load Clip node for loading the text encoder. Right now, I am using the highest quality one. If you are using the FP8 mixed or FP4 mixed, select those here instead. I'm using the highest one because I want to show you the maximum quality we can expect. Also, note that when I used the FP4 mixed, the generation was really fast. For the type, make sure it is set to Flux2, and for the device, leave it on default. If you are having out-of-memory issues, you can try the CPU option, but I'll be using default. The clip output then goes into the clip input of the positive prompt node. This is where we type our text. The conditioning output then goes to the reference latent nodes located in the multiple image loader groups. before coming back to the conditioning input of the Flux guidance node. Then the output from Flux guidance goes to the positive input of the K sampler. Since we don't need a negative prompt for the distilled model, the conditioning zero out node will act as a dummy input for the negative of the K sampler. So that node will have no effect on the image generation. Next, we have the load VAE node to load the Flux2 VAE. The VAE output is connected to all the nodes that require a VAE input. Now, let's talk about the image loader groups. In this workflow, we have 5 image loader groups, which can load 5 different images to create new composites. In each group, there is a load image node. The loaded image is rescaled in every group using the image scale to total pixels node. However, in the first image loader group, there are extra nodes designed to reduce pixel shifting in the generated images. I always suggest using this first group for your main image, as it is also the group used for setting the output resolution. Regarding those extra nodes, we have a VAE encode node that transforms the rescaled image coming from the image scale to total pixels node into a latent, and then we use a VAE decode node to transform that latent back into an image. We then use a getImageSize node to extract the width and height. That information is used to rescale the loaded image using the upscale image node, which then sends that rescaled image into another VAE encode node. This transforms the image into a latent and sends it to the reference latent, which combines it with the text conditioning and sends it to the Flux guidance node. The other image loaders are currently in bypass mode. When active, they also transform loaded images into latents and combine them with the text conditioning. A quick note, if you are not using the other image loader groups, I highly suggest keeping them in bypass mode. Otherwise, they can interfere with the image generation. Then reference latent nodes are connected to each other, then as I said before. The connection goes to the Flux guidance node, and that connection goes straight to the K sampler. Now, let's dive into the K sampler settings. I'm using a random seed with the steps set to 4, as the distilled model only needs 4 steps to generate an image. However, based on some tests, I've found that increasing the steps can actually improve the quality. For the CFG value, I'm using 1.0. The sampler is set to Euler, and the scheduler is set to simple. The denoise value is 1.0. Next, we have the empty Flux2 latent node. This is where we can set the output resolution, though right now, the resolution is being managed by the first image loader group. If you want to set a custom resolution, just remove those connections and set the resolution you like. The latent output of this node is connected to the latent image input of the K sampler. The latent output from the K sampler then goes to a VAE decode node, which transforms the newly generated latent into an image. Finally, the image is saved using a Save Image node. I've also included an image comparer from the RG3 custom node pack, just to compare the generated image with the original. Now that you have a basic idea of how this workflow is set up, let's start editing. We'll focus on single reference editing first. So let's choose another image in the first image loader group. I'm going to select this image of a woman sitting on the floor. Here's the plan. I'm going to add a hat to her head, so let's see how that works. Also, notice there is a float set megapixels node for setting the loaded image resolutions. Right now, it is set to 1.0, which means every image loaded into this workflow will be rescaled to a 1 megapixel image. If you want 2 megapixels, just type 2 in here. Now, let's focus on the positive prompt. I'm going to type, the woman in image 1 wearing a bowler hat. Now, let's run the workflow and see the result. So the first generation is complete. Let's take a look. As you can see, she is now wearing a bowler hat. That is very nicely done, and if we compare it with the original, you can really see the difference. There is a slight pixel shift visible in the generated image, but even so, I love the result. Now, what about the generation time? It took around 162 seconds, which is about 2.7 minutes. Remember, as I mentioned before, I am using the bigger text encoder, so the generation will be slower. Let's try another editing task. I'll choose a different image. This time, an image of a woman sitting on a chair. My goal is to remove the woman from the image entirely. So, let's go to the positive prompt and type, remove the woman from the image. Now, let's run the workflow and see the result. The generation is complete, so let's take a look. As you can see, the woman has been removed from the image. Unlike the previous attempt, there is very little pixel shifting effect in this version, so overall, this generation is really good. This time, it took around 145 seconds, which is about 2.4 minutes. Now, let's try changing the time and season of an image. For that, let's choose a different photo. I'm going to go with this image of alpacas. I'm actually in doubt, is it alpacas or sheep? Whatever they are, I'm going to change the image from day to night. Let's go to the positive prompt and start typing. Change the day to night, add a street lamp near the brown sheep. Is it an alpaca? Anyway, let's run the generation and see what the result is going to look like. Well, the generation is finished. Let's take a look at the result. This looks great. I really like how the shadows were created on the ground, and I also don't see any pixel shifting in this image. Now, how about changing the season of the loaded image? Let's do that. In the positive prompt, let's type, change the season to monsoon season, add greenery. Now, let's run the workflow and see what kind of result we get. Well, the generation is finished. Let's take a look at the monsoon scenery. The result looks good, and I don't see any pixel shifting in this one at all. Now, let's try a slightly different prompt to push it further. In the positive prompt, let's type, add dense green vegetation, trees, and foliage. Now, let's run the workflow and see what the result looks like. The generation is complete, so let's take a look at the result. As you can see, the image has a completely different vibe than before. I don't know if it's just me, but I've noticed that Flux2 models always try to add more saturation to the generated images. Now, let's edit something else. Let's choose this image of an anime character. This time, I'm going to transform this image into a photorealistic one. So, let's go to the positive prompt and type, transform this image into a photorealistic image. Now, let's run the workflow and see the result. Like I always said, the generation is complete. Now, let's take a look at the result. As you can see, this cute little kid looks completely real. If we compare the generated image with the original one, you can see that the model did a pretty good job. Now, what about transforming a photograph into an anime style? For that, let's choose another image. I'll select this photo of a cosplayer. Now, let's go to the positive prompt and type, transform this image into anime art style. We are all set. Let's run the workflow and see the result. The generation is complete, so let's take a look at the result. Overall, the result looks good, but if we look closer at her face, we can see there is a problem with her lips and the index finger of her left hand. There is also a slight issue with the ring finger on her right hand. We could do another generation to see if the result improves, but I don't want to do any cherry picking, so let's move on to another image editing task. How about generating a character sheet? Let's load another photo. I'll select this one of a woman sitting on a sofa. Now, let's go to the positive prompt and type, generate a character sheet of the woman showing front profile, back profile, and side profile. This time, we are going to use a custom resolution. Let's remove the connections to the empty Flux2 latent node and set the resolution to 1024 for both width and height. Now, let's run the workflow and see the result. The character sheet is done, and it's a great result for 3D artists. Even though the original photo was a kneeling pose, the model successfully generated a standing reference. I really like how it moved the hair in front profile and side profile that may help with the clothing details. The consistency between the front, back, and side views is really amazing. Now let's try something different, generating a blueprint of a car. Let's select another image for this task. I'll go with this white car. Now, let's go to the positive prompt and type, generate a blueprint of the car showing front profile, back profile, and side profile. We are all set, so let's run the workflow. Here is our blueprint. Let's take a look. Overall, it's not that bad. At first glance, we can see that the rear spoiler looks shorter in the front profile. Additionally, in side profile, the front splitter looks shorter in length. What's your take on this? Let me know in the comment section. Now, let's try restoring some old photos. I'm going to select this photo of children, which seems to have a lot of issues. Let's go to the positive prompt and type, restore the image and add colors to it. This time, we are going to use a resolution relative to the loaded image. To do that, let's connect the width output of the getImageSize node to the width input of the empty Flux2 latent node. Then, we'll do the same for the height, connect the height output to the height input. Now, let's run the workflow and see the result. So here is the restored photo. Let's take a look. This result is really amazing. I love how the model removed the unwanted artifacts and colorized the old photo so well. Now, let's try restoring another one. We'll choose this photo of a child and an old man. This time, we aren't going to change the prompt at all. Since the prompt remains the same, the generation is going to be much faster. Let's run the workflow and see the result. So here again is the restored photo. Let's take a look. As you can see, it looks much better than before, and I don't see any issues at first glance. Now, let's talk about the generation time. It took around 22 seconds, which is about the same time I get when running the FP8 mixed format of the text encoder. Next, let's try replacing the background of an image. I'm going to use this photo of a woman. Let's go to the positive prompt and type. Replace the background of image 1 with a sunset cityscape, no vehicles, cinematic golden hour lighting, shallow depth of field, and smooth bokeh blur. And that's it. While I was typing that, I actually lost power. In cases like this, it's a good idea to save your workflow so you can come back to it later. Now, an hour and a half later, the power is back on, so let's focus on replacing that background. Let's run the workflow and see the result. So the background has been replaced and it looks pretty good. I don't see any issues here. The woman has been relighted to perfectly fit the new background. Now, it is time to edit text within an image. Let's choose another one. I'm going to select this photo containing some text. Let's go to the positive prompt and type. Replace the text fantasy in image 1 with the text axiom graph. Now, let's run the workflow and see the result. And this is where the headache begins. As you can see, the model really struggled with this text. I tried 3 more generations to see if it could handle it, but it failed every time. After that, I tried to edit different text in a different image, and that time, the model successfully replaced it. It seems like the model has some inconsistent problems when it comes to handling specific text edits. Now, it's time to focus on multi-reference editing. This is where we take elements from different images and combine them to create a new composite. First, let's choose our main image. I'm going to select this photo of a red sofa. My goal is to take a kitten from another image and place it on the sofa. To get that kitten, let's activate the second image loader group. I'll right-click on the group header and select Set Group Nodes to Always. Now, let's choose our second image. Here is the photo of the kitten. Let's select it. Finally, let's go to the positive prompt and type. The kitten from image 2 sleeping on the sofa in image 1. We are all set, so let's run the workflow and see the result. The generation is complete, so let's take a look. It's a decent result, but I think the sleeping kitten looks a bit unnatural, so I'll just call it okay for now. Next, let's try replacing the texture of an image with a different one. First, let's choose our main image. I'll select this photo of a sofa. This time, we are going to replace the sofa's original texture with a new one. In the second image loader group, let's choose our texture. I'm going to select this photo of a denim jeans texture. Now, let's head over to the positive prompt and type. Replace the texture of the sofa in image 1 with the texture from image 2. We are ready, so let's run the workflow. So here is the image with the replaced texture. As you can see, the result is really good, though there is some minor pixel shifting. Now, let's push the model further and try using 3 reference images. First, let's select our main image. I'm going to use this photo of a woman. For the second image loader group, let's select an image that contains a specific outfit. Next, we need to activate the third image loader group. In this group, I'll select an image of a fairy hat. Here is the plan. I'm going to have her wear the sweater, pants, and shoes from image 2, while also wearing the fairy hat from image 3. Let's go to the positive prompt and type. The woman from image 1 wearing the brown sweater, pants, and brown shoes from image 2, while wearing the green fairy hat from image 3. We could also use the word also instead of while. Now we are ready. Let's run the workflow and see the result. The generation is complete, so let's take a look. Honestly, the result is just average. The pants look different from the reference, there are some issues with the shoes, and the fairy hat didn't turn out right either. Let's generate it again to see if we can get a better result and solve these problems. Here is the new result. This time, the fairy hat looks much better and is closer to the original height. However, the shoes and pants still failed to render correctly. Also, there is now a strange, extra piece of cloth under the chair. I have no idea why the model put that there. I also experimented with using 4 reference images. Sometimes it worked, and sometimes it failed, so I'm going to skip that part for now. Instead, let's focus on using a GGUF model in this workflow. To use it, you'll need a custom node pack called ComfyUI GGUF. Once installed, look for the node called Unet Loader GGUF. Simply add that node, select the Flux2 Klein GGUF model, and connect the model output to the model input of the K sampler. That's it. I also have a text-to-image workflow available, but I won't be focusing on it in this video. You can download that workflow from the description below. To wrap things up, I wouldn't say this distilled model is bad, but it isn't great either, as it struggled with certain editing tasks. I haven't tried the base model yet, so I'll check later to see if it performs any better. What do you think about these results? Please let me know in the comment section. Thanks for watching, and I'll see you soon in the next video. Don't forget to like, share, and subscribe to the channel.